The list is the most important data structure in Python. Now, when you look at online material, we normally cover what's important for beginners, such as the basics and list functions, which we covered in part 1. Elsewhere, there's a lot of details about data structures and algorithms, which we don't really want to repeat. In this video, we want to look at something a little bit different. Now, something we know about lists, when we remove an item, the items following that place where we removed the item will have to move up one. So if we remove the first item in a list, so in this example we've got A, B, C, D, E, F, and we remove A, then all of a sudden B, C, D, E and F have to move up a place to the index 0, 1, 2, 3, 4. Now, do we need to do that? In this example, we're just going to point to the place at the beginning of a list, and then we can point to the following values by adding 1 to the index. So we can see here we use X as an index and we point to A using X equals 0, and then we can point to the following items by just adding 1 to the index. Now, instead of deleting A in the list, we can just add 1 to the pointer, and we can still carry on accessing the next item, which would be C, then D, then E, then F, although we're not actually removing the item. So this is just an example of how we might implement some code. In data structure and algorithms, we look at how efficient things are, especially sorting algorithms. Now, Python sort, as well as Java sort, uses an algorithm called timsort. And this is kind of like a mixture of a couple of types of sorts, and it's quite efficient when it comes to ordering values that are already pretty much in order. So if we need to keep checking, let's say like a list of numbers, and maybe some are being placed out of order, but most of them are in order, then timsort is quite a good algorithm for that. So it's based on insert sort and merge sort, and it's good for, let's say, numbers that are already pretty much in order. Now, why is Python lists different from arrays in other subjects? Well, when we have an array in another subject, first of all we have to define it. We put define list here, but we mean like define arrays in other language. And normally we have to use the same data type. So other languages use array, and if you like, we have a value in a box and we need to know what's in that box and how wide it is. That's how we know where the items are in relation to the beginning. But Python doesn't do that with lists. So how does it not do that? How do we not need to define it? And how can we use Python with different data types? How does it allow us to do that? And what it does is it allocates memory as we add items. So you could say it dynamically adds memory or creates memory as the list grows. So how can we prove that, or how can we see that? Well, let's have a look at storage in bytes. Look at the bytes of a list in Python using getSizeOf. So if we look at the size using length, we will see how many items are in a list, but we can see how many bytes are in a list. So let's have a look at that code. We create X, an empty list, and then we're going to print the size in elements, which is going to be 0 because it's empty, and the size in bytes. When we run that, we can see we've got 64 bytes. Now, if we were to change that and perhaps add an element, you can see it's added some additional bytes. Now, it doesn't add bytes every time we add an element, but what does it do? Let's have a look and create a for loop, and we're going to add an element each time we iterate through the for loop. And we're going to print the length of elements and length in bytes. And here we can see that we start off with 64 bytes, that increases to 96, which stays the same until we've got 5 elements in the list. We've added more bytes. So we've added bytes after 4 elements and 8 elements. So we don't increase the size of the list when every new element is added, but it does dynamically increase over time when elements are added. So let's just try a range of 100, and we can see here that the bytes are steadily increased over 4 or 8 or different amounts of times when elements are added. So we started off 64, 96, 128, then 192, 264. So you can see the size in bytes increases to allow elements to be added to the list, but it doesn't do it every time an element is added. So we can say we start off in Python with a very limited amount of storage with an empty list, or a list with very few items, up to 4. But the storage increases as we add up elements or items, and as the number of elements in the list grows. So we can see here the code that we use get size of, and we use range to have an idea about when the changes occurred. So that's a new list in Python. So we can see that we increase the size in bytes at several stages. Now, why is that different in lists in Python than other data structures, for example? So let's have a look. Here we can see that a list uses more bytes than a tuple. Now, we can think of a tuple as a bit like a list, but it doesn't do as much. So it's good for temporary variables, but not very good for operations such as adding elements, which we can do in lists but we can't in tuples. So tuple is very limited, but it doesn't use as much memory and bytes as a list. So we can see we can increase the amounts of items in a list and a tuple. Here we've got 10 items in both, and we can see that the list is always first in the output. We've got 10 items and the bytes are higher, or we use more bytes in the list. The list is bigger. A set is quite large, but we don't really use sets in our normal code. So we normally use a list. How about a dictionary? Well, again, dictionary uses more bytes, but a dictionary is a bit more complex. Rather than accessing elements using a position, we access them using the key. Now, string is not as big as a list when it comes to bytes. So a string could be useful if, for example, we was storing digits from 0 to 9. We could quite happily use a string rather than a list. So a string is good for characters. But what happens if we wanted to store like numbers that were over 10? We wouldn't know the difference between 5 and 0 and 50, for example. So string's a bit limited on how we're actually going to implement it. But again, you can see the size when we use 10 elements, so from 0 to 9 in a list and 0 to 9 in a string uses a lot less bytes. Now, we can use lists most of the time, but if we're really concerned about size, we might use data structure from data science. So let's have a look at what they use in bytes. Here we can see a NumPy array. Now you can see the NumPy array, when it's empty, uses more bytes than a list. So why do we think a NumPy array, an ND array, is useful? Well, once we start adding elements, you can see now that they're starting getting closer in size. And once we get to something like 100 elements, now the list is bigger. Now, if we're going to use big data and large quantities of data, you can see here that the NumPy array is half the size of the list. So we can make a huge saving when we're using large quantities of data. Now, you might use Panda data frames, and the equivalent of an array in a Panda would just be one column, which is a series. And that's very similar size to an ND array. Okay, well, I hope you enjoyed that. It's a slightly different look at Python lists than you may have seen before. If you did like it, please give us a like. If you haven't already, please subscribe. We'll be bringing you more videos about data structures in the near future.